All right, I'm glad to welcome you. My name is Jim Randolph. I'm the Executive Director for the Illinois Ready Mix Concrete Association. And today we're presenting our webinar number 11, Concrete Pavement Myths. I want to say thank you for joining us. Thank you for joining us on this rescheduled webinar. I have some opening comments to go over here. And we have an antitrust statement that's available on our website. And this antitrust statement is available there to instruct us to refrain from any discussion relative to pricing or trade specifics, trade secrets, anything of a competitive nature. If you feel any of the discussion is not appropriate, just please raise your hand and I will recognize you. And if there is any media or uninvited guests with us, please drop off the meeting now. Thank you for that. This webinar is being recorded and it is being archived at our IRMCA website, www.irmca.org. At the end, we will take questions and answers. You'll find the Q&A on your Zoom toolbox, and you can ask questions anywhere along the way, but we'll wait till the closing of our webinar to answer your questions. We could not do these webinars without the help of our sponsors that you see listed here. And you go to these sponsors on our webinar tab, and you will be able to see at least three specific web links that they will point you to that's in respect to our webinars. And so that's just something extra special. You want to take time to look that up. We're sorry that we've lost our good friend and companion, our Assistant Executive Director, Theron Tobalski. Many of you know, passed away suddenly on June 18th of 2021. Theron was a champion for the concrete industry whose work and promotion efforts impacted our industry in Illinois and nationwide. Theron put this 12 webinar series together and he hosted each one. We'll miss him, but we'll cherish his accomplishments and his legacy for the ready-mix concrete industry that will live on for years to come. Our next webinar and final of this 12 webinar series is on July 28th, and the invitation for that will be coming out today after the conclusion of this webinar. The title will be New Concrete Industry Promotion on Concrete Trails, and it'll be presented by John Hanson, Senior Vice President, Local Paving of the National Ready Mix Concrete Association. Today's presenter is Luke McHugh, Professional Engineer and Senior Director of Local Paving at the National Ready Mix Concrete Association. Thank you, Luke, for your preparation, and we're glad to have you with us. And I will turn this over to you.
Okay, thank you, Jim. Can you see my screen okay?
Yes, and I will apologize to everyone. We're having a sound quality issue that is not on either of our ends, so stay with us, please, and we apologize for that. Yes, sir, Luke, your presentation is up and going.
Okay, thank you very much. So different today, just talk about some that I'll say errors and like have a little bit about the association. We are a national established in we are headquartered in Alexandria, and about 75% of the production of North America. The industry and our partners through operations, training, testing, governmental affairs at the national level, and then we have for structures is built with strength, pave ahead, which deals specifically on local roads and parking lots. If you'd be if you're to visit our website at www.membership. Again, my Northeast region for the NRMCA, my range is all of New England, Indiana, Illinois, and I do have colleagues that five who do cover the balance of. I've been practicing engineering for a large part of that emphasis had airport pavements. So, what I call the pave ahead top 10 lists about concrete pavement. It may not, it's the 10 I came up with, so that's what we're going to go with. So, when I design concrete pavement for limits, I just use Ashtone 93. Anyone is familiar with Ashtone 93? There are a lot of variables involved in that. You've got traffic in terms of equivalent single axle load. You'll see that thickness, several locations around the modulus of rupture for concrete. So if you're solving for the thickness process to come up with and then you basically guess at the match. The really goes back to the AASHTO. That's not a typo. That's what AASHTO was. So it's between 1950 and basically what the organization in the middle of Illinois, and they drove truck 7 days a week. They collected in load repetitions. And it says here that what they did there was what the pavement did based the traffic that was driving on those in 68 concrete pavement sections, 68 asphalt pavement sections. This was purely for highway pavement. Up with those test sections, well, they guessed asphalt and concrete. Here are some of the typical sections with asphalt and concrete. Pavement thicknesses there were in the neighborhood inches thick. And what they found was that through their testing, 90% of the asphalt pavement sections failed, 90% of the concrete pavement sections failed. So when your goal is, you really want to get really good asphalt data, but they concrete data. So what that shows, the sections were really over-designed. Grade is clay soil. So really they're only based upon how this particular soil type at this around the country. This is the first pavement design manual that about 2/3 of the way down the page says the pavement design procedures are for pavements on the state system only. are inappropriate for non-state aid parking lots. So really what they're telling you is that IDOT pavement design methodology, AASHTO methodologies as well. So what can engineers use for local Portland? There's what we call the design method by the American Concrete. Designs concrete pavements based upon two failure. What you have is you have slab flexure with slabs. And then there's erosion failure, which would be that load transfer at the joint. Also, a free web-based program methodology. It's called pavementdesigner.org. Collaboration between the National Ready-Mix Portland Cement Association and the American Concrete. So, briefly, I just want to get into using that method over what 93. These are two showed up on a project for Lowe's Home Improvement, Wilmington, North Carolina. So you had the asphalt on concrete pavement sections using AASHTO 93, ACI 330, and PCA, same traffic and the same type of subgrade. You can see that the concrete set areas was reduced from 6 inches to 0 stone subbase, and for the heavy-duty pavements, it was pavement on a 6-inch stone base to 6 stone base. The savings, the actual closed, but it's reported that for $1,000 just for going with the design method using ACI 330. Don't need to cure the concrete. Well, what is curing step during the construction process that involves maybe an adequate moisture and temp can develop properties such as strength and mix was designed to achieve. So with proper curing, concrete becomes strong. Strength that it was designed for, rapid at earlier ages, but continues here thereafter for an indefinite period. And it shows if you don't cure the concrete, that is much lower. That was 28-day strength. So you can see in this particular, the concrete strength at 28 days was 6,000 psi compressive strength. If it wasn't cured or cured improperly, that were much less than what that pavement were in the first place. And it also shows is that if you moist cure the concrete, that you get a higher than it was designed for at a 28-day stretch. Concrete, it really gives you predictable strength of pavement's durability, and overall appearance on your pavement surface. So there are concrete. Curing materials can be in the forming compound, which is a water molecular film forming materially for the application to fresh concrete. Have an absorptive cover or a moisture retaining cling film or a white burlap in the pictures there to the right. Number 8, pavement. So I need a thicker aggregate base course. If we look at how a flexible pavement has an asphalt typically, and then you've got various aggregate course, a sub-base course, grade soils. And the way a flexible pavement works, pavement layers, both the aggregate, work together to support that real structural purpose in supporting that load. When we look at a rigid pavement, concrete layer really handles load being applied to that pavement. So the flexure of that concrete and the tensile strengths pavement that support that wheel load. You'll notice for that aggregate layer down below the very, very little structural. The thing is the load is encompassed. We'll take a little bit of look at that soil. A couple things I'm going to talk about here. A modulus of subgrade, or the California bearing ratio. These are two that describe your subgrade soil. The K load per unit area of soil to the car typically evaluated in place required to force a standard piston divided by the load required to form graded crushed stone in accordance with some ASTM standards. So if you're under CBR value from your geotechnical report, and if all else fails, you can get the soils which are available online. The K value is typically a value or a high value based upon whether you've got sands and gravels. K values that correspond to that support values. So this is a table that's in, and what you see here is 100, that if you have an aggregate, you get a slight increase in your, and by adding 6 inches, it says that support that much further. If we look at the 8-4 pavement sections, one thing I want to point out here is 100, and we have a modulus of rupture of 6, and we have a typical traffic spectrum. That corresponding thickness of pavement unreinforced. And just to show the K value factors into that, the K value of 200 concrete thickness by ½ an inch, and you have a very of a K of 500, it only concrete off that pavement thickness. So you can see that the K on overall pavement thickness. Number 7, to open the pavement to traffic. Well, why is it always the guys wait 28 seconds? So when can you open? There's a few rules of thumb. One is to have an in-place compression PSI or 75% of until the pavement is accepted by the engineer. If he's testing that concrete pavement by here's a sample of an intersection. It was the intersection closure over a 3-day weekend. So at the start of the prior to relocated traffic, so they constructed, then they shifted traffic over and constructed areas down below. And then over the week intersection, over 3-day weekend closure. So look at the weekend closure. They at 8 p.m. They removed the head all graded and prepped by 8 Friday morning. Then they started 3 p.m. They were sawing the joints. And on Sunday, they have it. So, do you need to wait 20? Concrete pavement achieves the design up your pavement to handle traffic. Some ways that you can do that while the inner traffic. There's 2 ways here. You can either construct it by quadrant if your traffic safely around those. So in each of these show that the pavement is traffic is being relocated around that construction area. Number 6, it's concrete, so it's easier to finish. Well, you should never bless concrete finisher. I hope that answers your question. That we don't want to bless to the concrete surface as we're finishing it with dusting. So you get unhydrated cement that forms on the surface. And then surface where you get scaling. So you at the surface of your concrete pavement. Can you add water at the job site? Yeah, to increase slump, but only if a portion is held back and the slump is low by design. You want to add the water to the and you want to make sure that the slump or the is also not exceeds exercises in accordance with AS. So how do you want to place it? You want to place the concrete so that it's placed in its final procedures that avoid segregation. You want a level surface without sealing. Wait for the concrete to stop proliferations. You want to texture the surface as required. Just finish it so that you're able to get elevations that you want. You want to saw cut the joint. Try to do that as soon as possible. How long should I wait to saw cut the joint? 24 hours. It really depends. Temperatures are. It depends what the humidity is. That you get a hot, windy day. Well, you want to saw cut those joints as soon as possible. Or most importantly, cure that pavement. Number 5, concrete pavement. Well, why do you need steel? Okay, something like number 4 bars placed across pavement. Unfortunately, that's reinforcement. It does not make the concrete stop the concrete from cracking. The only thing cracks tighter when the pavement does crack. This is what you may see when you've got guys may try and lift it. So this is what you end up bottom of the pavement, which it's not do in the first place. If you want to add material, the better way to go would be to add fibers. You'd be looking at steel, exterior pavements. You're looking at the microfibers, which are the smaller, really just for plastic shrinkage, crack control. The macro fibers are those, they're probably about 2 inches long. They look like very coarse hairs. And in some cases, they will provide cement. It's really on and they should be designed accordingly to secondary reinforcement. In cases with that secondary reinforcement, you reduce the thickness of your pavement section. Sometimes steel is necessary, so we have down load transfer. They should be cut. They should be free of burrs. If required, we recommend smooth round steel. Epoxy coated bars are recommended to de-icing salts. There's also either rectangular, also not listed here, but would be hollow dowels successfully as well. And so it takes less install those dowel baskets as well. Form bars that prevent slabs from moving in. The table here shows the sinks typical for number 4 bar on chairs or other supporting and are incidental. Those chairs also provide no structural value as well. Number 4, my pavement. Well, concrete will crack. Life that are certain. Death, taxes, and concrete will crack. Concrete crack, it's because it shrinks. If the concrete slab is not restrained at any point, so there wouldn't be any cracks. And you've got an aggregate base, or even the soil being restrained at that surface, or it cracks. So the recommended spacing to control cracks from forming is really 3 times the thickness of the concrete. Have a 4-inch pavement, then we want joint spacing, and anything over 6 inches, you're looking to be in that 12, range. Some designs may call for closer to load transfer considerations across the joint. The graph demonstrates the relationship between slab. You can see here that as the or becomes stiffer, decreases. So if you have cases where you have a stable pure concrete pavement, you really want to consider joint spacing or joint spacing your spectrum. As I said, rules of joint spacing and slab dimensions. 2 to 2.5 times the depth and times the given thickness in inches, and odd shaped slabs possible, but if you square, you can't keep them square. Ratio down to 1, the length width ratio, but I'd recommend more than probably 1.25. When we look at our joint, take a look at corners and acute angles. You can see here that we want to convert, and whether that curve formed integral curve that, or if you've got a curve and gutter type system, the joint comes in. You want to make sure that that in perpendicular to the curve, somewhere 2 feet away from the curve face, that joint to then propagate over to the curve. Any type of intersecting, the picture down at the bottom that really cut that joint, that it's perfect. The edge of the slab to try and get that joint over by that angle coming into the slab. Where you've got an inlet coming in, entrance corners coming off the inlet, and that crack's going to want to form. So you have the saw cut joint before you get to the, that's really what you want to consider. Holes. So you'll see here that the concrete where it wanted to, instead of where it's placed with that acute angle. So we're down to number 3, stronger. It does, but what shrinks, is the strength of the concrete. To decrease to do that, typically they add more cement, which is required, which means for hydration. This is shrinkage and to potentially to crack. The aggregates aren't going to shrink. It's the, if you have lower pace content, aggregate grading, how much paste is optimized gradations, less paste water demand, however slump and work the same as mixtures with single volumes. So what this shows you is if you have, we're mostly the same size or a small same size, it's you're gonna have more surface area. Paste is gonna be required to coat. If you have a well-graded mixture, less paste and less water, thereby pavement. We talked about strength. Strength is fine, but is a durable pavement. And how do we make that durable? So we want the pavement to withstand de-icing salts and reactivity. So we want quality aggregate, adequate cement, and entrained air in our mix. We need our contractors and who are committed to producing quality work. Concrete, at the end of the day, when the finishers go working and transforming from a wet mixture to a solid pavement. I hear this all the time up in we want to keep water expands at 9% of water than water, and those continuous concrete pavement with the pressures that expansion causes. Pavements can't be built in northern climates. Well, a couple examples here in northern climates. We've got this couple of roundabouts up in Wisconsin. We've Washington County, Minnesota. This is the Burlington, Vermont. Super 8 Motel pavement here is probably at right now it's probably at and has had very little maintenance. You can see where some of the aggregates are starting to, but all in all, this looks pretty good for 20-year-old pavement. Up in Charlton, Massachusetts, is that typically up in New England pavements, this was a project where coming down the hill, and the pavement that used asphalt intersection. That asphalt intersection has been milled twice since the original concrete. On the left is the original concrete construction. So what are we going to do to reduce the risk of this in northern climates? We want to use a low water in that 0.4 to 0.42 range. Use the appropriate cementitious materials, whether it's slag. You also increase the durability using materials that are all industries. And we want to make sure we have adequate air voids to pavement can withstand those freeze-thaw cycles. We want to pave at all locations so that the joint, and if possible, make sure that we don't have joints that we may have in low areas. We're applying a penetrating sealant, low water infiltration and salt pen to the microstructure of the coat. So limit the use of aggressive salts after that further pavements are constructed. They will eat your pavement. Should always limit what those deal that first winter. That can be soft, even though it's hardened. So we've come to the number one, and that is that concrete is all pavement. But it doesn't have to be. Well, and here's how. Okay, I already talked about today. We don't need to have steel that you may need it at the joint or to tie those slabs to get the steel in the mat itself is really unnecessary. Eliminate that steel, the steel of the joints. That's correct. You've got where the is not the controlling design factor, interlock that can safely and effectively transfer against the joint. So in thinner, let's say a parking lot for a retail center or McDonald's, you really don't need consider eliminating those. I can decrease in some areas. If adequate, you can eliminate the need for, I will say that an aggregates will help provide a for constructing that concrete pavement, and that seems to be, say, the rule of thumb, especially area. I don't have to improve this. Look at how the subgrade really can be overall support provided by a poor subgrade. And going to affect your overall concrete thickness. I should use ACI for concrete parking lot pavements. You want to be for local roads and streets, ACI 325. Those are the two you can use to design those concrete pavements. You can use materials to reduce cement. That's true. And silica fume to help reduce the overall cost so that it is more competitive or to an asphalt pavement, and it also improves durability at the same time. Your pavement maintenance costs. So when you look at pavement to an asphalt pavement, when it comes to life cycle costs and what you need to do to, I won't say that concrete pavements are, but they are much require much less to asphalt pavements. So having to seal coat the pavement if you control, and typically it is maintained properly, it should serve years to come. And lastly, you can construct no matter what the climate. When north, with concrete paved properly, they can function just about anywhere. 10, I just want to go over briefly that NRMCA can also assist you with, and how IRMCA as well. We have a website. So if you go to paveahead.com center, you can us. We will provide support signing or coming up with pavement section, and any joints that we can provide and views as well. We do costs with respect to asphalt picture review, and that's for any ready mix type, pervious concrete or compacted concrete, cement slurry, in use reclamation of asphalt pavements. One last NRMCA's concrete works is coming up in late September to early October, and that's Florida. So thank you very much. That concludes my formal presentation, and over to Jim Randolph at this particular time.
Thank you, Luke. And I realized you had to speak kind of slowly there to be sure that we could hear you well enough. Again, we'll look into what those technical sound problems were. But as I look, I don't see any raised hands or any questions. Just a reminder that everyone will receive a PDH following this webinar. And we want to say once again, thank you very much for joining us. Again, if you have any questions, go ahead and go into the Q&A box down below now. Hope you're having a great summer in full swing. And that was a great presentation on the myths. And we certainly have a lot of success stories out there regarding concrete pavement and concrete overlays. And so definitely those of you that are designing, call on Luke. You can give us a call at RMCA. We'll all hook up together for these free services in designing. So again, I don't see any questions coming up. Luke, thank you very much. And we want to say thank you again to our sponsors. And with that, remind you of our upcoming webinar number 12 on July the 28th. And we'll be sending that information out today or tomorrow. And so we hope to see you then again as we wrap up this series. So thank you very much, everyone, and have a great rest of the week.